Hello everyone, welcome back to RareChem Official. Today we are going to learn about formal charge. If you like this video, please like, share and subscribe. Without delay, let's get started. Definition: formal charge of an atom in a polyatomic molecule or ion is the difference between number of valence electron of that atom when it is in free state and number of electrons assigned to that atom in the Lewis structure in the given molecule. First, covalency of atoms. For carbon, maximum covalency is 4. For nitrogen, maximum covalency is 4. Oxygen, maximum covalency is 2. Silicon, 6 maximum covalency. For phosphorus, maximum covalency is 5. For sulfur, maximum covalency is 6. Chlorine, maximum covalency is 7. First, Lewis dot structure. These are the rules to write Lewis dot structures of any molecule. First rule is selecting central atom. For central atom, least number electronegativity is least, and large size. Hydrogen and fluorine can never be central atom because these are the smaller size than other elements. So hydrogen and fluorine can never be central atom. Oxygen, sulfur, nitrogen, phosphorus, carbon, silicon, chlorine. These are the examples. Octet of the corner atom must be complete. Central atom tries to remain in maximum covalency. If positive charge is present, it will be on the central atom. If negative charge is present, it will be on corner atom. If take ozone, first we have to count total number of electrons present in the molecule. For nitrogen, 6 valence electrons present in the oxygen. So 6 into 3 equals to 18. If write ozone O3, 1, 2, 3, 4 bond pairs are present now. 18 minus total, if subtract these 4 from total electrons, we got the 14. These are the lone pairs. First we have to fill lone pairs for corner atoms. How many lone pairs are present? 14. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 12 electrons are we used. 2 lone pairs are on middle oxygen. Okay. If how many electrons we used? 14. Now these 1, 2, first 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. The corner atoms satisfy the octet rule. If come to middle atom, 1, 2, 3, 4, 5, 6. See, 6 electrons present. Means it has 2 electrons less to octet rule. Still it wants to 2 electrons to complete the octet. See, if 2 electrons as a bond, this oxygen also satisfy the octet rule. Now if you count electrons 1, 2, 3, 4, 5, 6, 7, 8, the middle atom also satisfy the octet rule. If formal charge is equals to total valence electrons minus lone pair electrons minus bond pair electrons divided by 2. For oxygen, for ozone, we can calculate. If this oxygen as a first atom, this oxygen taken as a second atom, this is third atom. For first atom, if you calculate formal charge, the total valence electrons is present in the oxygen in free state. Means oxygen has 6 valence electrons. How many lone pairs? 1, 2, 3, 4, 5, 6. 6 lone pairs. How many bonded pair electrons? 2 electrons divided by 2 equals to, we got the minus 1. Minus 1 is the formal charge for first atom of oxygen. If take second atom of oxygen, 6 valence electrons are present in free state. How many lone pairs? 2 electrons. And how many bonded pairs? 1, 2, 3, 4, 5, 6. 6 by 2 equals to, we got the first one, plus 1. Plus 1 charge is the formal charge for second atom of oxygen. If take third atom, 6 valence electrons are present in free state, and how many lone pairs? 1, 2, 3, 4. 4 minus how many bonded pairs? 1, 2, 3, 4. 4 by 2 equals to, we got the 0. 0 is the formal charge for third atom of oxygen. Means minus 1 plus 1 0. If take N2O, total valence electrons are present in N2O is 6. For nitrogen, 5 electrons are present. 5 into 2 is 10. For oxygen, 6 valence electrons are present. So total number electrons are 16. Write N2O. How many bonded pairs? 1, 2, 3, 4. If these 4 subtract from total electrons, we got the lone pairs. First we have to fill these lone pairs for corner atoms. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How many lone pairs? 12. 12 lone pairs are we used for corner atoms. Now this nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen satisfy the octet rule. Coming to this oxygen, how many electrons are present? 1, 2, 3, 4, 5, 6, 7, 8. This oxygen also satisfy the octet rule. Coming to second nitrogen atom, how many electrons? 1, 2, 3, 4. 4 electrons. It has 4 electrons, means it has four electrons less to octet rule. If write these 2 electrons as a bond, how many electrons are present? 1, 2, 3, 4, 5, 6. Still it wants 2 electrons to complete the octet. Now these 2 electrons as a bond. Now oxygen nitrogen atom satisfy the octet rule. See, 1, 2, 3, 4, 5, 6, 7, 8. Now second atom of nitrogen also satisfy the octet rule. Octet. These two Lewis dot. These two are the possible Lewis dot structures for the N2O. If coming to formal charge for N2O, first atom of nitrogen, formal charge, how many valence electrons present in valence state, free state? 5. How many lone pairs? 1, 2, 3, 4. 4. How many bond pairs? 1, 2, 3, 4. 4 by 2. 5 minus 4, 2 by 4 by 2 equals to 2. We got the minus 1 charge, formal charge for first nitrogen atom. If calculate formal charge for second nitrogen, how many valence electrons? 5. How many lone pair electrons? No lone pair electrons, 0. Minus how many bond pairs? 1, 2, 3, 4, 5, 6, 7, 8. Say 8. 8 by 2. We got the plus 1. Plus 1 charge for second atom of nitrogen. Oxygen formal charge. How many valence electrons present in free state? 6. How many lone pairs? 1, 2, 3, 4. 4. How many bond pairs? 1, 2, 3, 4. 4 by 2. We got the 0. Formal charge for oxygen. For this molecule, formal charge for nitrogen, first nitrogen atom, how many valence electrons present in free state? 5. Total number of how many lone pairs? 2. Minus how many bond pairs? 1, 2, 3, 4, 5, 6. 6 by 2. 5 minus 5 equals to 0. 0 is the formal charge for nitrogen atom of first nitrogen atom. Second nitrogen atom, formal charge. The valence electrons present in free state for nitrogen is 5. For second atom, here no lone pairs are present. So 0. How many bond pairs? 1, 2, 3, 4, 5, 6, 7, 8. 8 by 2. And we got the plus 1 charge for second nitrogen atom. For oxygen, formal charge, How many valence electrons are present in free state? 6. How many lone pairs? 1, 2, 3, 4, 5, 6. 6 minus 6. How many bond pairs? 2. 2 by 2. We got the minus 1 charge for oxygen atom. Now, third possible structure of N2O. First nitrogen atom, formal charge. Total number of valence electrons present in free state? 5. How many lone pairs? 6. How many bond pairs? 2. 2 by 2. We got the plus 2 formal charge for first nitrogen atom. If calculate second nitrogen atom, the formal charge is plus 1. The valence electrons in present in free state 5. Here no lone pairs are present in second nitrogen atom, so 0. How many bond pairs? 1, 2, 3, 4, 5, 6, 7, 8. 8 by 2. We got the plus 1. For oxygen atom, formal charge, how many valence electrons present in free state? For oxygen, 6. 6 minus how many? Here 1, 2, 3. How many lone pairs? 2. How many bond pairs? 1, 2, 3, 4, 5, 6. 6 by 2. We got the plus 1 charge, formal charge for oxygen atom. Now if you observe, compare for all three structures. See here, this is one of the possible structure for N2O. Here we got triple bond means for oxygen covalency is maximum covalency is 2. For here 3 triple bond is formed. Now this is wrong. Now if you observe between two possible structure of N2O, here formal charge for oxygen we got the 0. Here formal charge for oxygen is minus 1. Carbon, nitrogen, oxygen. Electronegativity increases from left to right. Oxygen is more electronegativity. So oxygen has plus 1 charge is the best Lewis structure for N2O. Okay. If take NH4 plus, total electrons for NH4 plus is, valence electrons present in the nitrogen is 5, and for hydrogen 1 valence electron is present. 4 into 1 plus 1 means we have to remove 1 electron from this, and total electrons are present in NH4 plus is 8. If you write NH4, the H is satisfy the duplet structure 1 2 3 1 2 1 2. Now if count electrons for nitrogen 1 2 3 4 5 6 7 8. Nitrogen also satisfy the octet rule. If positive charge is present, we have to put the positive charge in central atom. Already we studied the rules for Lewis dot structures. Positive charge is present, we have to put the positive charge in the central atom. If take NO3 minus 1, total electrons present in NO3 are 24. If you write NO3, how many electrons, how many bonded electrons? 1 2 3 4 5 6, and 6 electrons. If you subtract from total electrons, we got the 18. These are the lone pairs. If fill these lone pairs for corner atoms first, 1 2 3 4 5 6, 1 2 3 4 5 6, 18 electrons we fill for 3 oxygen atom. If count for oxygen atoms, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8. 3 oxygen atoms satisfy the octet rule. If observe for nitrogen, 1 2 3 4 5 6, nitrogen is not satisfying the octet rule. If write these two electrons as a bond, nitrogen is 1 2 3 4 5 6 7 8. Now nitrogen also satisfies the octet rule. If count formal charge, it is taken as a first atom. First atom oxygen formal charge. How many valence electrons? 6. How many lone pairs? 1 2 3 4 4. Bond pairs 1 2 3 4 4 by 2. The formal charge is 0 for first atom of oxygen. For second atom of oxygen, the valence electrons are 6, and lone pairs, how many? 1 2 3 4 5 6. 6 minus bond pairs 1 2 2 by 2 equals to minus 1. Minus 1 is the formal charge for second atom of oxygen. If count formal charge for third atom of oxygen, 6 valence electrons are present in free state. 6 lone pairs are present. 1 2 3 4 5 6. 6 minus 6 minus how many bond pairs? 1 2. 2 by 2 equals to, we got the minus 1. For nitrogen atom formal charge, if we calculate, the valence electrons are present in nitrogen are 5, but minus how many? Here no lone pairs are present. Now we didn't write any lone pairs. How many bond pairs? 1 2 3 4 5 6 7 8. 8 by 2, we got the plus 1 charge. Plus 1 charge if we have present in on the molecule, we have to write the on the central atom. If negative charge is present, we have to put the negative charge on the corner atoms. Okay, thank you for watching.